Greetings everyone. I welcome you to yet another lecture of circuits and system. So today we are going to go with graph theory part 2, and before starting up with the lecture I would request those who haven't watched the graph theory part 1, please go through with that channel with that video first. So the link of the video is given in the description below. So starting up with today's lecture, it is on graph theory part 2. Here we are going to start with network analysis, and we are going to see some networks having mutual inductance. So always remember students, an investment in knowledge pays you best interest. So if you are investing your time for gaining knowledge today, you'll always get the best thing in your life. So moving ahead. So there is a question. In this question, they have already given you a graph. They want you to express branch voltages in terms of node voltages, branch current in terms of loop current. Okay. So as we already know that we can always make an incidence matrix from a completely oriented graph. So we made an incident matrix, and now from this incidence matrix, I've removed this row because we can still have a complete incidence matrix from here itself because the sum of the column is 1. देखिए हमें पता है ना कि कॉलम का सम 1 रहेगा, तो इस वजह से हम अपने फिफ्थ नोड को हटा सकते हैं. So to get the branch voltage, what we do, we have a formula. हम यूज करते हैं VB is equals to A transpose into Vn, where Vn is nothing but node voltages. अब अगर हम इस मैट्रिक्स को कंसिडर कर रहे हैं, दैट इज आवर इनकम्प्लीट इंसिडेंस मैट्रिक्स, तो हाउ मेनी नोड्स आर लेफ्ट? वी आर लेफ्ट विद 1 2 3 4 nodes. So you used 4 node voltage, we have used 8 branch voltages, and we are just multiplying this to get the branch voltages. Similarly, we want to calculate the loop current. For this we need a tie set matrix, and as we know, when we make a tie set matrix, we try to make those matrices in the forms of twigs and links. Here, we haven't made that matrix in the form of twigs and link. We've just used all the branches. But my first tie set, which contains a loop from 1, 2, and 5. So this is the loop I am considering. So I have made the tie set matrix. Now, using the equation, IB, that is my branch current, is nothing but transpose of my tie set matrix, transpose of my tie set matrix into my loop current. So how many tie sets are there? 1 2 3 4. That is tie set 1 made with link 1, made with link 4, made with link 6, made with link 8. So I have labeled it IL1, IL4, IL6 and IL8. So in this way I'm expressing my branch current in terms of my loop current. Okay, so you can take the screenshot. Okay, moving ahead to the next question. Now, again, they have given us the graph. Okay, and they have given, write down the basic Tyson matrix. They have given the trees branch as well, taking a tree of branches 2, 4, and 5. So we have taken 2, 4, and 5. We have made the tree. Okay, and we have to write down the KVL equation. Here, since there is no circuit given to us, so we write down the simplest KVL equation, that is B Tyson matrix into branch voltage is equals to 0. So this is my simplest KVL equation in terms of branch voltage and tie set matrix. So we just have to simply get down the tie set matrix. We have to multiply it by branch voltages, and we have to equate it equal to 0. We'll get all the voltage equation in terms of my KVL. So these are the parts. This is how we analyze networks with graph theory. Now comes the major question. So this question has already been asked in the examination. Okay. So at that time, they didn't ask about the equation. They asked about finding out the tie set matrix, finding out the incidence matrix, finding out the cut set matrix. But they can surely ask for the other parts as well. So this is the given circuit. Now in this given circuit, always remember to mark that given 2 volt is Vs. That is the source voltage. Now, IS, any current source given to us? No. So value of IS will be 0. I'll just put it clean. So since source voltage is not, source current is not given to us, so I'll take the value of IS is equals to 0. Okay. Now, same way, I've removed the branches which are at the outer level, taken the tree. Okay. Now, making the links, I've got my tie-set matrix. Okay. So, what are the links for which I'm getting the tie-set matrix? Link is 1, 2, and 3. We can say loop matrix or we can say tie-set matrix. Okay. Now, moving to the first part. So, the first part says find the KVL equation. Now they want us to calculate loop currents and branch currents. Okay, so they want us to calculate loop currents and branch currents. Okay, so moving ahead. So for loop current, obviously it already specifies that we want a loop matrix. So what is my KVL? So my KVL says my B matrix into my impedance matrix, that is ZB, multiplied by B transpose into my loop current matrix is equals to B matrix into my source voltage, that is Vs, minus B into ZB into Is. Now for the given question, remember this thing, Is is 0. So this part will already be 0. I'll just mark it with some other color. I'll not. Okay. So this part is already 0 because Is is 0. Now, how to write this ZB? Now see it carefully. How to write ZB? See, I've taken all the branches. So how many branches I have? I have 6 branches. So in my first branch, I have a resistance of 1 ohms. I have a resistance of 1 ohms. There is nothing else. If there would have been one more resistance, I would have added that to this branch. Okay. So I have a resistance of 1 ohms in the first branch. Second branch, again 1 ohm. Third branch, again 1 ohm. Branch fourth, which is from here till here, I have a 2 ohm resistance. So it's a 2 ohm resistance. Third 2 ohm, fourth 2 ohm. Okay, so I have mentioned all the resistances available over here. Now what I've taken, I've got my B transpose over here. Now Vs, now Vs is 2 because my voltage source is in the first branch. Clear everyone? My voltage source is in the first branch, or rather is connected to my first node. Okay. So now I've got all the branches. I've got the branch Vs. I've got my B transpose. Now I'll start calculating. So B into ZB, B into ZB into BT, and B into Vs. So now this is the equation which I've got as B into ZB into B transpose. This is this multiplied by IL. So my loops are 1, 2, and 3. IL 1, 2, and 3. I've got my BVS. This is nothing but B times Vs minus, it was already given to be 0. So I've got my loop currents, value of my loop current 6 by 7 ampere, 4 by 7 ampere, 4 by 7 ampere. Clear everyone? Just to save times, I have given all the calculations over here. Okay, clear everyone? Now, since I already have my loop currents, I can always find out my branch current. My branch current IB is nothing but B transpose into loop current. This we saw in the very first example. So B transpose into my loop current is going to give me my branch current. So what does this say? This says in branch 1, if I say this is I1, this is I2, this is I3, I4, I5, I6. So these are the value from I1 to I6. Is it clear, everyone? So at times, and there are chances, there are good amount of chance that they'll ask you to plot all the matrices and they may ask you to go ahead and find the loop equations. Moving ahead. Now, here's the question where there is a mutual inductance over here. And see, this is mutual inductance over here. Now, you already know how to make a graph. You already know how to make a graph. You know how to make a tie-set matrix. So you have made the tie-set matrix as well. Now, in this question, the biggest point is how to write ZB. How to write ZB. Now see, how to write ZB. Now ZB, in branch 1, I have a 3 ohm resistance and I have an inductance whose impedance is given to me as J 4 ohms. So I have 3 plus 4J as my total impedance in this branch. But if you see, there is a mutual impedance, that is, which has been caused by this inductor to this branch. So from this inductor to this branch. So this gives me an additional value of J3, because this will be acting over here also. And with last branch, it does not have any connection. Similarly, when I go with branch 2, this J3 ohm is having an effect on this branch as well. So I'll be taking J3 ohm. The impedance of this branch, J5, rest is 0. There is no such problem with this branch. So 0, 0 minus J8. So this is how I get ZB. This is how I get ZB. So you have to see what mutual inductance is given over here. Clear everyone? So you have to check what mutual inductance is given over here. Is it clear everyone? Hopefully yes. So you can just take a screenshot. The formulas are same. See, BVS, IS is given 0. So this term will come 0. This term becomes 0. So I have the same formula, BZB into BT into IL. Now, till now what we have seen? We have seen for KVL equations. Now we need to calculate the KCL equations. KCL, Kirchhoff's current law. Again, the given circuit is given to us. They've given the voltage source. They've given all the values of the resistance. They want us to calculate the twig voltages. Okay. So now let's start. If they want us to calculate twig voltages, so I need to go with a cut set matrix, because number of cut set matrix depends on number of twigs we have. Okay. So we have found out the cut set matrix. Now the formula of KCL changes from Q to YB. YB is nothing but admittance. Admittance matrix. And those who are not clear with admittance, the unit is mho. And if you want to go ahead, it is 1 by ohms. So I can say admittance Y is nothing but 1 by Z. Okay. So it's Q into admittance matrix into Q transpose twig voltage is equals to Q times IS minus Q times Q into VB VS. It's not Q times, Q is the matrix. Sorry. So again, there is no current source. So value of IS will be 0. If they would have given us a current source, okay, let us say they would have given 1 ampere, then this IS would have taken part as 1 ampere. Is it clear? So for now, we don't have, so we are not considering it. We are not considering it. Now, how to write admittance matrix? Now see, again, first row, I have a resistance of 5 ohms. So 1 by 5 is nothing but 0.2. 1 by 10 is nothing but 0.1. That's it. These are the two values. So all the rows, all the branches having 0.5 or 5 ohm resistance has been given the value 0.2 ohms. One of them is having 10 ohms resistance. So 1 ohm, 2 by 10, 5 ohms, and so on. So we have just used 1 by R, or rather 1 by Z is equals to Y, admittance matrix. So this is how I get the admittance matrix. You've taken the Q transpose. I've got the value of Vs given to me. That is 910 volt. Now finding out all the values, multiplying and getting to the equation where I can find out the twig voltage is Vt. So this is how we are using graph theory to calculate all the parameters of the circuits. Clear everyone? You can take the screenshot. Now, just for the practice sake. Now, these are the four basic formulas which we have used. We have used branch voltages in terms of node voltage. So it is given by VB into A transpose into Vn. So VB into A transpose into Vn. So next, branch current in terms of loop current, that is IB is equals to B into IL matrix. Is it right? Or there is something missing? There is a missing part. It is B transpose into IL, loop current. Now KVL. KVL we have used. We have given the branch voltage, that is VB. B into VB should be equal to 0. This is the simplest KVL we have used. Now other KVL is where we say we have to find out all the current equations. So we say we start the KVL by B times ZB into B transpose into IL is equals to B times VS minus B ZB IS. This is my KVL equation. KCL equation, Q into YB to QT into VT. VT is twig voltage, is equals to B times IS minus, or rather Q times IS, sorry. It's not Q times, it's Q into IS minus Q into ZB into VS matrix. So these are the equations which I've used in order to find out all the values. You can go through, you can take the screenshots from the video and you can practice it. So these are the questions which are expected and they may come in this year's examination. So thank you. And always remember, little drop of water makes the mighty ocean. As I've always said, your little efforts will gain you good marks. And please help the universe by liking, subscribing, and sharing the channel so that we can grow and we can make things easier to learn. So thank you, my dear students. All the best.